In this video, we'll continue to look at coordinate geometry. Now, we'll be looking at this question. Now, the question says, the coordinates of the points A, B, and C are 0, 4, 2, 3, and minus 1, 9, respectively. The midpoint of BC is M. Find the equation of the straight line through M perpendicular to AM. Now, many times the students see the word perpendicular in a question on coordinate geometry and automatically think the equation of the perpendicular bisector to any line that is mentioned, but that is not always the case. So what I did basically was to try to go ahead and represent the points in the XY plane so we can get an idea of what exactly we're being asked to do. So it is not, these points weren't plotted, as you can see, they weren't drawn to scale, but just a general idea of what of where the points would lie, right? So basically what we have here is a point 0, 4, which of course would lie somewhere on the y-axis. We have the point C, minus 1, 9. So minus 1 is to the left of the y-axis, and up here is the point C, minus 1, 9. And you have the point B, which is basically as coordinates 2, 3. Good? Now we're told that M is the midpoint of BC. So the midpoint of BC is M. So we basically call this point here M, which is the midpoint of BC. And what we're really asked to find, we want to find the equation of the straight line through M, which is perpendicular to AM, right? So we're not asked to find the equation of the perpendicular bisector of AM. No, we're asked to find the equation of the straight line through M, which is perpendicular to AM. So if we were to basically draw a line to show AM, if let's say this is a point A and this is M, let me try to represent this properly. So let's say this is a point M and this is A, then this is our line AM, right? So this would be our line AM. What we want to find, or what you're asked to find, is the equation of the line which passes through M and is perpendicular to AM. So this line would basically look something like this, right? I'm trying to draw it as accurately as possible, right? So based on our AM, the direction of AM, then this line of course will be passing through the point M and will of course be perpendicular to AM. And if we want, we could just basically call this line something. Let's call it, let's put a point P there, and Q, obviously it passes through the M, so we can call it PMQ. So basically this is a line that they want us to find the equation of. And as I said before, it is not the same thing as a perpendicular bisector of AM, right? So let's proceed and find what we want to find. Now, the first thing we need to do is to find the coordinates of M, which is the midpoint of BC. So once again, let's write down these points. So we have the point A, which is 0, 4. We have the point B, which is 2, 3. And we have C, which is of course minus 1, 9. Right? Now once again, we're told that the midpoint of BC is M. So let's go ahead and find the coordinates of M. So the coordinates of M would be equal to, so it's midpoint of BC. So we're going to add the x coordinates of B and C, divide by 2. So I missed out the C here. So let me just insert the C. So this point is C minus 1, 9. Right, so let's now go ahead and find the coordinates of M, the midpoint of BC. So to find the midpoint, of course, we'll add the x coordinates and divide them by 2. So this is basically going to give us minus 1 plus 2 over 2. And we'll do the same thing with the y coordinates. So 3 plus 9 over 2. Right? And so this gives us that M is equal to minus 1 plus 2, that is 1. So that's a half. And of course, 3 plus 9 is 12. 12 divided by 2, that is 6. So therefore, the coordinates of M, the midpoint of BC, is a half 6. Good? So once again, we're asked to find the equation of the straight line passes through M and is perpendicular to AM, right? So because the line passes through M, we will use the coordinates of the point M. But now we need to find the gradient of AM in order to find the gradient of any line which is perpendicular to AM. So once again, A is a point 0, 4, And so we can say that the gradient of AM so A is a point 0.04. So if we look at what we're doing here, if we just label it as say x1, y1, and this one as x2, y2, then the gradient of course will give us y2 minus y1 over x2 minus x1. And so the gradient of AM is given by 6 minus 4 divided by a half minus 0. So this gives us 2 divided by a half. Dividing by a half, same thing as multiplying by 2. So this gives us 4. So the gradient of AM is equal to 4. But we're not asked to find the equation of AM. We're asking to find the equation of the line which passes through M and is perpendicular to AM. So we know that when it comes to perpendicular lines, the product of their gradient is equal to minus 1. So if two lines are perpendicular, the product of their gradient is equal to minus 1. In other words, the gradient of one line is the negative reciprocal of the gradient of the other. So since the gradient of AM is equal to minus 4, the gradient of any line which is perpendicular to AM, right? So the gradient of any line perpendicular to AM would be equal to minus 1 over 4. So the negative reciprocal of the gradient of AM. So now that we found the gradient of that line, we now have our point M, which has coordinates a half, 6, and we have the gradient which is equal to minus a quarter. And so this is basically what we will now use to find the equation of the desired line, right? So using y minus y1 equals m times x minus x1, we get that y minus 6 is equal to minus a quarter times x minus a half. And so this gives us, after we expand the brackets on the right hand side, we have y minus 6 is equal to minus a quarter x, right? Then minus a quarter times minus a half gives us 1/8, right? And so bringing the 6 across, we get that y is equal to, same thing as minus x over 4. Then we have plus 1/8 plus 6. So the 6 goes across to the other side, so it becomes a plus 6. But of course, 6 can be expressed as a fraction with a denominator 8. And that fraction, of course, would be 48 over 6. What am I saying? No. Yes, 48 over 8, right? And so this becomes y is equal to minus x over 4 plus 49 over 8. And this is the equation of the line that we're asked to find. So this, of course, is the equation of the line which passes through M and is perpendicular to AM, where M is the midpoint of the line BC.